Okay, class, today we're going to learn about what's called the partial quotients division algorithm. Now, those four words sound very confusing, but if you break them apart, we know that partial means partly, quotients is the answer in a division problem, and a division algorithm is simply a way of doing a division problem. We know that there are different ways to do different types of problems, different ways to do addition problems, different ways to do multiplication problems. I'm going to show you a different way of doing a division problem. I especially like this algorithm for dividing numbers with two-digit divisors. I think it works really well for that, but we'll start with a pretty easy division problem. First of all, I'm going to have my dividend be 782. We'll start with that. And my divisor is going to be 4. Now in the traditional method, we would divide 7 by 4 and keep track of our numbers this way. In the partial quotient division algorithm, it's a little bit different. You can tell that you're using this algorithm because I can tell kids are using it because I see a line going down the side of the division bracket. And what I do is I try to talk to kids about how we want to make as big of a chunk out of that 782 as we can with our divisor. What I mean by that is if I just multiplied 1 times 4, I would get the answer of 4. And I could take that chunk away from 782. And when I do that, 2 minus 4, I have to regroup. 8 becomes 7, 2 becomes 12, that's 8, 7, 778. So you could see that if I kept taking chunks of 1, 4, we'd have a long way to go to break down this number into the different groups of 4. So rather than taking a chunk of 1, 4, I'm going to take a chunk of, say, 100 4s. So I'm keeping track of these numbers on the side. And what I need to do is probably move this guy. Let me go back. Move this guy over, and I'll show you that why that's important later. So I'm going to take a chunk of 100 4s. Well, 100 4s is the same as 400. And when I take that away from 778, I'm left with 378. Now I still have quite a big number, but you can see I've reduced it by 400. I couldn't do another 100 though, because that would be too much. But I could maybe do 50 4s. And what I'm going to do is with that 0 and 50, I'm going to put that in my answer. And then I'm going to multiply 5 times 4, and that's 200. So I just took a chunk of 200 away from that, what was remaining, 378. And when I subtract that, I get 178. Now I couldn't do another group of 50 because that was worth 200, but I could do maybe a group of 20. So 4 times 20, put the 0 here, again, like we did from the 20, and 2 times 4 is 8. Now I just took a bite of 80 away from 178, and that leaves me with 8. 17 minus 8, that's 9. 98. Now I see this number, and I notice this number. It looks like I could take another bite of 100. I say taking a bite. I like to take big bites. 20 times 4 is, again, 80. We've already done the math with that. And what I have left is 18. Now I've got this number down to a very reasonable number. 18 divided by 4. My last piece would be 4, because I know that 4 times 4 is 16. And you can see now I'm left with a remainder of 2, which is less than my divisor, so this is all the farther I can get. So I need to keep track of these numbers, so I add them up. That's why I had moved that 1 over so that it's in the ones column. So 1 and 4 is 5. I'm adding this, by the way. 5 and 2 is 7, 8, 9, and 1. So my answer is this number, 195. And I have a remainder of 2 fourths. And as a bonus, some of you would realize that a better way of saying 2 fourths would be 1/2. So 782 divided by 4 is 195 and 1/2. So I'm going to show you that from the beginning and talk about the different parts. Go all the way back. There we go. So it looks like a traditional division bracket. And what I do is I draw a straight line down the side. And this is where I keep track of the chunks of 4 in this case that I'm taking off of this dividend of 782. The first thing is I showed you that if you took chunks of 4, which would be 1 times 4, that would be a lot of chunks that you'd have to take. And we'd go from 782 only down to 778. So it's better to take a bigger chunk. And I thought, well, why not take a chunk of 100? 100 times 4 is 400, and that's a lot bigger bite. And you'll notice too, I slid that 1 over so that those numbers are lined up when I add them later. So when I took that 400 away from 778, that left me with 378. I couldn't take another 400 out of it, so I thought, well, why not take a chunk of 50 out? So then I'm going to multiply 50 times 4, and that turns out to be 200. So I've subtracted 200 from 378, and that leaves me with 178. Couldn't take another chunk of 50 because 178 doesn't give me enough. So I take a chunk of 20. I put the 0 down below the 8, and now it's 2 times 4, like we've done multiplying zeros before. 2 times 4 is 8, so 20 times 4 would be 80. And when I subtract that, I have 98. And I recognize that. And I said, well, why not another chunk of 20? Since that was 80, and I have enough to make another chunk of 20. Took another 8 away. That left me with 18. Now, this is a very simple division problem. 18 divided by 4. I know that 18 divided by 4 is 4. So 4 times 4 is 16. And when I subtracted them, I got the remainder of 2. The next step in this partial quotient algorithm is to add up all of the answers that you've kept track of on the side. And that ended up with 195. Move that over so you can see 195, and we had a remainder of 2. So that would be reported as 2/4. But again, 2/4 is better to be written as 1/2. Looks like my 1/2 got covered up. 1/2. So the answer is 195 and 1/2.